So, here we're looking at tree diagrams, and we've just looked at rolling dice. We're going to simplify a little bit now. Get it right back to basics. Here we've got, what do the H and T represent? Heads and tails. What's the probability of us getting a head on a random coin flip? 50-50. How do we write that? 1 over 2. And what about tails?
1 over 2.
Okay. Let's say we flip a head on our first coin. What's the odds of us flipping a head in our second?
1 over 2.
Tail on our second? Same thing, but now we've got tail on our first head. And tail? Very good. So how many times will we flip the coin?
2.
Twice. Very good. So if I flip my coin twice, what are the odds that I will get 2 heads? How did I get 1 over 4, Riley?
4 different outcomes.
There's 4 different outcomes.
One of them leads to.
Only one option leads to success. Very good. So Riley said successes basically divided by trials. We have 1 success over 4. Is there a mathematical way we could do it? Olivia?
Times the first one by the second one.
So I can multiply. I could say, well, PRHH equals 1 over 2 times 1 over 2. With multiplication, tops by the tops, bottom by the bottoms, gives us 1 over 4. Does that feel about right?
Yes.
About 1 in 4 times? My next one at least 1 head. So what does at least 1 head mean? What are the things that are we going to classify as a success? Brody?
Ones that have at least 1 head.
So let's go through the scenarios. So the top part, does it have at least 1 head?
Yeah.
It's got 2 heads, so that clarifies. Up then down,
Yeah.
down then up, and then down then down. Okay, very good. So what are we identifying there? What's the probability of getting at least 1 head? 3 over 4, how'd you figure that out?
There's 4 trials for 3.
So you did the successes. I'm just going to write S over T, and you've said, well, there's 3 successes over 4 trials, 4 possible options. Very good. Is there a mathematical way we could work it out? If these weren't even probabilities, could we do that? No, we'd have to think of a different way. How could we go about it?
You times all the successes, the probability of the first and second trial, you times them for the 3 successes, and then you add them together.
So you could say
So it'll be
1 over
plus 1 over
2 times 1 over 2 plus
Yeah.
1 over 2 times 1 over 2 plus 1 over 2 times 1 over 2.
Yeah.
Very good. And that will give you 1 over 4 plus 1 over 4 plus 1 over 4, which gives you
3 over 4.
3 over 4. Very good. Anyone see another way of doing it? I didn't do it like that. I did it a different way.
The reverse.
The reverse.
The 1 take probability. So it would be
So you've
no
got
heads,
1 minus the probability of
no heads.
no heads.
Or only heads.
Very good. So what's 1 in probability terms? It means it's
Oh.
certain, it's whole, it's definitely going to happen. If I flip a coin, it will be either heads or tails. I've never seen a coin lay up on its side. But you bottle flippers with your coin flipping, I'm sure you figured out a way. Huh. So Jack, what's the probability of no heads? Because I've got 1 minus. So how many of those pathways lead to no heads? What do you reckon?
I don't know.
Does the top path lead to a head? Let's run through them. Let's have a look. Okay, well let's run through it. I've flipped 2 coins here, Jack. Happy with that? In the first scenario, let's flip a heads. On the second coin, I flip a heads or I flip a tails. What's the probability of half for each flip? So on the first one, do I get a heads? Second one, have I got a heads? Third one, heads? Fourth one. So how many of those options had no heads? One had it out of 4. So I can represent the probability of not getting a heads as 1 over 4. Very good. So 1 over 4. What's 1 minus 1 over 4? Who's dealt with fractions and mixed numbers before? No one? What do you reckon? How do you know it's 3 over 4?
Because when you say, so if you can put 1 into 4 over 4 and just say 1 over 4 is 3 over 4.
Very good. So what Jacob just says, he's going to represent 1 over 4. Sorry, 1 as 4 over 4. Is that the same?
Yeah.
It's just saying I'm cutting my pizza into 4 parts, isn't it? And then if I'm keeping all 4, I'm cutting them into 4 parts, but I'm keeping them. And then I'm going to subtract 1 slice. How many slices have I got left? 3/4 of my pizza. Same answer. So sometimes it's easier to go the certainty minus the other options, and sometimes it's easier to add up all our options.